Welcome you all in SST College of Arts and Commerce. This is SST Edupedia. Myself Shagun Tiwari from Department of SYCS and CS. Today we'll start with the software engineering course and the topic name is Introduction to UML Diagrams. So first of all, what is UML? So UML is nothing but the Unified Modeling Languages. So UML is modeling languages used to express and design the document softwares. So particularly it uses the object oriented design. It's not a process, but some have to be being proposed using UML. So it is independent of the implementation language. Why we use UML? So we use UML for the representing our system into the graphical form. So we use this language to initially design our specific detailed design across the entire software development life cycle. It increases the understanding of the communications of the product to the customer and the developers. It supports for the diverse application areas and supports for the UML in many software packages today. For example, Rational, plugins and NetBeans, Eclipse, everywhere. So it's basically depends upon the experience and the need of the user community. So now here we'll understand the three important terms of the UML diagram, which is nothing but the system, models and the views. So model is nothing but the subset of the main system. View is nothing but the selected aspects of any model, and notations is nothing but the graphical or the textual rules for the views. And views and models of a single system may overlap each other in many cases. For example, system aircrafts model. Here, if for example models are nothing but the flight simulators and the scale models, and views could be all blueprint, electrical wiring and the fuel system. If we take the example, diagrammatic example of the system, model and view. So here you can see we have an entire system. There we have two different models and three different views. Okay. So if aircraft is a system and we have two models, the first model is nothing but scale model. Second model is flight simulator. And if we talk about the views, so blueprints, electrical wiring is nothing but the views. Okay, so this was the example about the UML diagram where we discussed system, model and views. Now we'll see what is UML model view diagrams. Okay, so here UML is nothing but the multi-diagrammatic language. So each diagram is a view into a model. So diagram presented from the aspects of the particular stakeholder, or it provides the partial representation of the system and systematically consists of the other views. So we can have many views. For example, 4 views is there in case of the use case. So logical view can be there. We can design the logical view of any system by using UML diagram. We can also design implementation view, deployment view and the process view of any system by using UML diagrams. If we go to the diagrams, UML diagrams, so there are 9 diagrams, main diagrams. So they are divided into 2 parts, static views and the dynamic views. So static views means its working is same, and dynamic view is nothing but which we can change at any instance of the time. So first diagram is nothing but, in case of the static view, it's object diagram, second one is component, third one is the deployment diagram and fourth one is the activity diagram. If we come to the dynamic views, so state chart diagram is there, collaboration diagram is there, sequence diagram, use case diagram, class diagrams are there, which represent the dynamic view of any system. Here in this video, we'll only talk about the use case diagram in detail. Okay, first we'll see how many views can be there. Okay, means if we are going to represent a system, so there are n number of views can be there. So in that case, it's not necessary to represent all the views. We can drop as per our requirement. We can drop the views, just like examples are there. In case of the single processor, we can drop the deployment view. In case of the single process, we can drop the process view, and in case of the very small program, so there we can drop the implementation view. So, and we can have more than these views as per our requirement or the requirement of any system. So we can also have data view. So data view will show the interaction of data overall the system, like how any system is collecting the data and how it is processing and how it is giving the output. Okay, and we can also have the security view as well. So if we talk about the first pass of the UML diagram, so if you can model 80%, so we can represent 20% of the UML diagram. So 20% of model can be explained, or we can also say that 20% of the functionality of any system can be explained by the UML diagrams. So the basic modeling steps for the UML diagrams is nothing but the use case, which captures the requirement. After that, we do the domain model, which captures the processes and the key classes. After that, design models. So design models, there it can capture the details and the behavior of the use case and the domain objects, and classes that do the work and define the architectures. It can be there. If we go for the baselines of the UML, so use case diagrams are there, class diagrams are there, package, interaction, sequence, interaction diagrams are divided into two parts, sequence and the collaboration, activity diagrams we can give, state transition diagrams can be there, deployment diagrams could be there. So these are nothing but the basic UML baselines. So now we'll go with the use case diagram. As I told before, we discussed use case diagram here. So use case diagram is used to represent the behavior of the system. So here we take actors and the use case in the consideration. Actor is nothing but the just like any role or any person or user of the system can also be known as actor. So for example, customer. So customer is nothing but a kind of actor. After that, use case. So use case basically is used to represent or sequence of the interaction or summary of any scenario. So here, as you can see, passenger is nothing but the actor and purchase ticket, it's an action. So here it is also known as use case. Now actor. So actor is nothing but the model means the external entity over here. Any external system, physical environment or user are considered as the actor. So actor could be having unique name and the optional description you can give in case of the use case diagram. So for example, any passenger of the train, or in case of the library system, if we design any library management system, so over there students or the librarian, they both are nothing but the actors. The main actor is nothing but the user or the student. Student are the actor for the library management system. Okay, now in case of the use case diagram, So use case is nothing but the functionality of the system. It is nothing but the event flow as well. The event which is occurring in any kind of system can also be known as a use case. Okay, so use case basically consists of unique name, participating actors, entry condition, flow of event, exit conditions, and the special requirement can be there in case of the use case diagrams, in case of the use case. Okay, and it is represented by the oval shape. So oval shape. Okay, after that, use case diagram example. If we take one example of use case diagram, so here name of the system is nothing but the purchase ticket. So participating actor will always be the passenger because they need the tickets. Okay, so entry condition means the user should means passenger is standing in the queue in front of the distributor, and definitely they should be having the enough money to buy the ticket. So these are nothing but the entry condition. Exit condition, if a passenger will get the ticket, then they will leave. So this is nothing but the getting a ticket is nothing but the exit condition. Event flow. So passenger first will select from where to where he or she has to travel, and after that it will ask the distributor what will be the amount, and it will pay the amount, get the ticket from the distributor, and then it will leave. So this could be the event flow. So this is the scenario which is considered in case of the use case diagram. Okay, so if we want to represent these cases in the form of diagram, so here you can see the diagram. Okay, so first of all, before that we'll talk about the extend relationship. What is extend relationship in case of the use case diagram? So extend relationship basically represent the exceptional cases or exceptional invoked seldom invoked cases. Those are known as extend relations. Okay, so these relations are represented as arrow-headed towards the use case. Okay, which is extending that relation. So the exceptional event flows are factored out of the main event flow for the clarity, and use cases representing the exceptional flow can extend more than one use cases, and the direction of the extends class, as I told you, it will be the relationship is to the extended use case. Now the next relationship is nothing but the include relation. So we can see here the collect money is nothing but the include relation of purchasing ticket and the purchase multi-card. Okay, so include relation represent the behavior that is factored out of the use case. Okay, so include behavior is factored out of or reuse, not because it is an exceptional case. Okay, so include relationship is to the use case, unlike the extend relationship. So use case are useful to determining the requirements. The new use case often generate the new requirement as the system is analyzed and the design takes shapes. So, and communicating with the client can be done by using use cases. So their notational in simplicity makes use cases diagram a good way for the developers to communicate with the client and generating the test cases. So the collections of the scenario for the use case may suggest a suite of the test cases for those scenarios. After that, so here in this video we studied about that use case diagram represent the external behavior. Use case diagram are useful as an index into the use cases, and use case descriptions provide meat of the model not the use of the diagrams, and all the use cases need to be described for the model to be useful. Okay, so many use cases diagrams we can take, we can show. You can, for example, you can take any system and then you can represent that system into the use case diagram easily by representing actor and the use cases. In case of many software development, we complete the use case diagram in the requirement elicitation phase only. Okay, so we can show this use case diagram to the customer that this will be not, this is nothing but the flow and working behavior of your system. Okay, thank you.